Hello guys, good morning. Welcome to the 8th lecture of Magnetic Compass online lecture series. Today in this class we'll discuss about deviation due to permanent magnetic force. Let's start. Let's do some recap. We already know that a ship's magnetism is divided into two distinct categories. One is permanent magnetism, another one is induced magnetism. This permanent magnetism is also categorized in three categories. One is 4.5 component, another is other ship component, another one is vertical component. 4.5 component we call them as P force, other ship component is defined as Q force, and vertical component is known as R force. The P force will act in the 4.5 direction and it will cause some deviation. Q force will act in other ship direction, it will also cause some deviation. However, R force, it will act in deck to kill or kill to deck direction, but when the vessel is upright there will be no deviation. How this deviation will occur we'll see in the following slides. We already know that if we have got blue pole at the bow we call them as plus P force, and if we have got red pole at the bow we call them as minus P force, right? Let us see what are the effect of plus P force uh, in the magnetic compass and how this plus P force will create deviation to the magnetic needle, right? So when the vessel is 0 degree heading, we see that the compass needle is here and we have got a plus P force. So we have got a blue pole at the forward and a red pole at the astern, right? So when the vessel is on the 0 degree heading, so that time as we have got a blue pole at the forward and red pole at the stern, and this is aligned, this blue pole and red pole is aligned with magnetic meridian, this compass needle will not have any kind of deviation. However, directive force can be decreased or increased, but there will be no deviation, right? But if the shape alters its course to 045 degree, what happens? We have got blue pole just beside the red pole, and uh, red pole we have got this needle, red side of the compass needle is just beside the blue pole, and it will be attracted by the blue pole and the compass needle will deviate a bit, right? How it will deviate? It will do some deviation like that, right? So we will get some deviation, right? And when the vessel is 090 degree course, that time it will have maximum deviation, right? And it will deviate like that. Again, when the vessel is 135 degree course, that time it will have some deviation and will have small deviation, and when the vessel is 180 degree course there will be no deviation. Why? Because this compass needle is fully aligned with magnetic meridian, and blue pole and red pole is also aligned with magnetic meridian, so that's why the directive force will be increased or decreased, but there will be no deviation. Whereas when the vessel is 225 degree course, that time there will be some deviation, and the vessel is 270 degree course, that time the maximum deviation will occur, and when the vessel will go to northwesterly heading, that means 215 degree course, that time there will be some deviation. And if we take this deviation, is position deviation, and we put it over here in this graph, so for northerly course we have got no deviation, northeasterly course some deviation, easterly course maximum deviation, then southeasterly course some deviation, then southerly course no deviation. If we make a graph and if we take this value from this picture, the graph will look like that, right? And it looks like a sine curve, right? So that means for P force there will be a sine curve, and if it is a plus P force, that time the deviation, maximum easterly deviation will occur on the easterly heading, right? So if we want to get the properties of deviation due to plus P force, we can say that in the plus P force, in the easterly courses easterly deviation will occur, and in the westerly courses westerly deviation will occur, right? And this deviation, as it is like half of the circle, we call it, this deviation is a semicircular deviation, and deviation varies as sine compass course, right? So this is the uh, effect of plus P force on ship's compass needle, and I want you guys, you please uh, make a deviation cut for minus P force. Let us see what are the other ship component we have. We know that on board ship we have got the other ship components, and that other ship component we call them as Q force, and this Q force can be two type. One is plus Q force, right, and another one is minus Q force, right? Let us see what are the effect will have due to the plus Q force, right? Here we have got a ship. This ship is kept in 8 different heading: 0 degree, 045, 090, what is that? That is 090, then plus 45 degree, that means 135 degree, then 180, then 225, 270, 315 degree, right? So that is the 8 heading. Let's see in different heading what type of effect or what type of deviation we get due to plus Q force. So when the vessel is on 00 degree heading, you see that red pole of the compass needle will be either attracted by the blue pole or deflected by the red pole, and that's why we'll get maximum deviation. And for plus Q force we get the maximum easterly deviation, and when the vessel is on the northeast heading there will be some deviation, and when the vessel is on 090 degree heading there will be no deviation at all. Why? Because this compass needle will be fully aligned with the magnetic meridian, and the blue pole and red pole of the ship is also aligned with the magnetic meridian, so there will be no deviation, but there will be increase or decrease of the directive force, right? Now when the vessel is on the southwesterly courses, that time there will be some deviation, and again when the vessel comes to the 180 degree course there will be maximum deviation due to plus Q force, and this deviation will be on the westerly direction, right? And again when the vessel is on the southwesterly course, that time there will be some deviation, and when the vessel is on westerly course, that means 270 degree course, there will be no deviation, and when the vessel is on the northwesterly course there will be some deviation. And if we take these values and we put those values in this graph, we'll get a graph like that, and this graph is look like uh, a cost curve, right? So that's why we can say that the deviation due to Q force will follow a cost curve, right? And if we write down the property, we can tell that in this due to plus Q force there will be easterly error in the northerly courses and westerly error in the southerly courses, and just like of plus P force, the plus Q force deviation is also a semicircular deviation, and this deviation will vary as compass course, because this curve is a compass curve, right? I want you guys to make a deviation curve due to minus Q force. Right now let's see what are the effect of vertical component. We already know that this vertical component of the ship permanent is acts on either top to bottom or bottom to bottom to top, depending on the construction process, right? So here you see, suppose if it's a plus R shape, that time we'll get a attraction towards downward, but this attraction will not create any kind of deviation curve, right? So in all heading attraction will be on the downward, right? Again in for minus r force, there will be a deflection upwards, and this in all heading that deflection will have, and it will not create any curve. So from this lecture we understand that for for p force we get a sine curve, and for q force we get a cosine curve. And I want you draw this curve and keep it ready for your future reference, so that we can create the coefficient. Thank you very much.